5 Filipino supervolcanoes are awakening simultaneously and shocking scientists, because what is happening across the Philippines has never been recorded in human history, and it could trigger the deadliest volcanic disaster our planet has ever seen. Picture not one, but multiple supervolcanoes scattered across different islands, all showing signs of life at the exact same time. Taal volcano's crater lake is boiling. Mount Pinatubo is venting steam after decades of silence. The Laguna caldera, which has not erupted in 29,000 years, is registering ground swelling that has experts in full panic mode. This is not coincidence. This is a geological nightmare unfolding in real time. These are not ordinary volcanoes. We are talking about supervolcanoes that have the power to change global climate, block out the sun, and trigger worldwide famine. Pinatubo's 1991 eruption cooled the entire planet for 2 years. Now it is waking up alongside giants that dwarf even its destructive power. But here is what is terrifying scientists. Underground magma chambers, once thought to be totally separate, might actually be connected by hidden pathways deep beneath the archipelago. If one supervolcano erupts, could it trigger a chain reaction that turns the entire Philippines into a volcanic wasteland and plunge the world into a new ice age? That is what experts fear, and that is where our story begins. Sirens blare across Negros Island as Kanlaon roars to life. On June 3, 2024, a column of ash and gas punches 5,000 meters into the sky, blotting out sunlight over entire villages. Sulfur burns in the air. Ash settles thick on rooftops, fields, and schoolyards. PHIVOLCS scientists scramble, racing up mountain roads blocked by panicked crowds. Their radios crackle with urgent calls. Ground inflation is accelerating. Seismic sensors show a relentless drumbeat of earthquakes, and sulfur dioxide readings have shattered every previous record. By midday, airports across western Visayas are forced to close. Flights are grounded as pilots report zero visibility, and engines risk choking on volcanic grit. Ashfall blankets Iloilo, more than 80 kilometers away, turning day into a gray, choking dusk. Local hospitals fill with people struggling to breathe. Farmers stare helplessly as crops wilt under the toxic dust. Power lines sag, and water supplies turn sour from acid rain. The eruption doesn't stop with a single blast. In January and again in May 2025, Kanlaon unleashes new waves of violence, each explosion hurling pyroclastic debris down the slopes, sparking wildfires that race through the sugarcane fields. Emergency crews battle flames while villagers flee, clutching children and livestock. Roads jam with evacuees as officials issue orders for tens of thousands to leave the danger zone. Some refuse, haunted by memories of past disasters and unwilling to abandon their homes. PHIVOLCS field teams set up mobile labs at the edge of the exclusion zone. Every hour, they download new deformation data. The ground is swelling faster than anyone has ever measured here. Scientists speak in hushed tones about magma pressurization, warning that the worst may not be over. Their faces are streaked with sweat and ash as they log readings and send urgent bulletins to Manila. The sense of dread is palpable. One wrong move, one missed signal, and the eruption could escalate beyond anything the region has ever faced. As darkness falls, the only lights are from emergency vehicles and distant fires on the mountainside. The island holds its breath, caught between fear and the hope that the worst has passed. But with each tremor, each plume of ash, it's clear. Kanlaon is not finished yet. Dr. Maria Antonia Ramos stands before a wall-sized map dotted with red triangles and swirling seismic traces. Her voice cuts through the static of alarm. Not every volcano with a violent past is a supervolcano. In volcanology, the line is drawn at the Volcanic Explosivity Index, VEI, where only eruptions that eject at least 1,000 cubic kilometers of material reach the mythical VEI 8. The Philippines, despite its fearsome reputation, has never recorded an eruption on that scale. Even Pinatubo, whose 1991 blast changed the world's weather, measured a VEI 6. That eruption blanketed Luzon in ash, forced the evacuation of Clark Air Base, and dropped global temperatures by half a degree, but it was still an order of magnitude smaller than a true supereruption. Yet, the archipelago hides giants beneath its seas and valleys. The Apalaki caldera, discovered in 2019 beneath the Philippine rise, is the largest known caldera on Earth. 150 kilometers across, dwarfing Yellowstone and Toba. Scientists mapped its boundaries using bathymetric sonar, tracing a collapsed volcanic dome so vast it's only visible from space. But Apalaki's last eruption happened millions of years ago, and there's no sign of reawakening. The Laguna caldera, scarred by an ancient blast 29,000 years ago, shows only subtle ground swelling, nowhere near the rates that would precede a catastrophic event. Taal and Kanlaon, both restless, are closely watched, but their recent activity falls within the normal range for this volatile arc. Dr. Ramos points to the real-time monitoring feeds. Seismic swarms, gas emissions, and ground deformation are the signatures experts scan for. PHIVOLCS teams deploy GPS arrays, tiltmeters, and satellite radar to catch the first hints of magma rising. So far, none of the Philippine volcanoes have shown the runaway inflation or gas spikes that would signal a VEI 8 threat. The data is clear. No mega eruption is brewing. But the sheer scale of these calderas and the memory of Pinatubo's global impact keep the world's eyes fixed on the archipelago. In the halls of government and science, pressure mounts to upgrade monitoring before the next disaster tests the limits of preparation. A single unmarked envelope lands on the desk of the National Emergency Planner. Inside, a ledger stamped "Confidential" lists numbers that seem almost impossible. 50 billion pesos allocated for a contingency that officials hope never leaves the vault. The planner's pen hovers over columns marked with code names and evacuation routes, each one tied to a volcano, each one a gamble against time. In the margins, handwritten notes tally up the logistics. Food rations for 500,000 people, fuel for military convoys, medical stockpiles for field hospitals that may never see daylight. The drills begin before dawn. Sirens wail through empty city blocks as actors play out the chaos. Families herded onto buses, soldiers sealing off roads, helicopters waiting by the runway. The numbers are staggering. 150,000 projected evacuees if just one caldera erupts. Up to 500,000 if the chain reaction scenario comes true. Every hour of rehearsal is a reminder that the plan must work perfectly the first time because there won't be a second chance. In closed-door meetings, the planner faces a wall of screens, maps lit up with red circles, spreadsheets crawling with cost overruns, live feeds from satellite phones in the exclusion zones. The pressure is relentless. One memo, marked urgent, warns of a cascade event that could push the country to the brink. Food shortages, riots, the possibility of martial law. Another details classified drills for moving entire barangays by sea should the roads become impassable. Every scenario ends with the same question: how many can be saved and at what cost? Each signature on the ledger carries a private weight. The planner's own notes, written in a tight, anxious hand, ask whether the drills are enough, whether the billions spent on logistics, bunkers, and medical caches can outpace a force that doesn't follow any timetable. As the next budget cycle looms, the numbers on the page blur with the faces from the last evacuation drill. Children clutching bags, elders refusing to leave, officials barking orders into radios that might go silent when the real disaster hits. Roberto Balbalusa sits on the edge of a bamboo bench, his hands sifting through a box of relics darkened by decades-old ash. His voice is steady, but low. He remembers the day the sky over Pampanga turned black, how the world shrank to a single room, lit only by candles and the blue flicker of distant lightning. Ash drifted through the cracks in the nipa roof, piling on the altar and the family's battered Santo Niño. For nights, thunder, and the smell of sulfur pressed in from every side. Roberto's diary, its pages brittle and gray, records the silence before the mountain broke open. We heard nothing at first, only the dogs barking. Then the ground moved, and we knew Pinatubo was waking. Every morning now, Roberto sweeps fresh dust from the steps. Each tremor rattles the glass on the shrine. He keeps the old radio close, waiting for the next alert. The memory of 1991 is never far. Crops buried, rivers turned to mud, whole villages vanished beneath the weight of ash. The world outside moved on, but in Roberto's mind, the eruption never ended. Warnings come, but the fear is the same. We live with the mountain's anger. At a weathered desk in Angeles, Teresa Reyes, once a meteorologist at Clark Air Base, thumbs through yellowed logbooks. She recalls the endless shifts, tracking cloud heights and wind direction as the base prepared for evacuation. The air was thick with static, radios alive with codes and clipped voices. Each alert level brought a new wave of dread. Would the next plume drift toward the barracks or away into the jungle? Teresa's notes capture the exhaustion of those days. Eyes stinging from ash, lungs raw, every forecast a guess. We watched the sky for signs, but the mountain did not care. For both survivors, the present feels like an echo. Roberto's grandson asks why the sun sometimes disappears at noon, why the old people pray so loudly when the ground shakes. Teresa still listens for distant rumbles, her body tense at every tremor. Their stories are written in the dust that settles on photographs and in the prayers whispered at dusk. Each artifact, a rosary blackened by ash, a diary entry scrawled in candlelight, reminds them that behind every government drill and scientific bulletin, there are lives shaped by loss, memory, and the hope that the next eruption will spare what little remains. Arguments erupt behind closed doors at the PHIVOLCS headquarters. On one side, Dr. Maria Antonia Ramos stands with a stack of satellite printouts and seismic charts. She points to the latest tomography slices, jagged, color-coded cross-sections that hint at deep, shadowy anomalies stretching beneath Luzon. The images suggest something unsettling. Faint corridors where magma might move silently between volcanic systems once thought to be isolated. Isotope ratios from gas samples collected at Taal and Kanlaon show unexpected similarities, as if the volcanoes are somehow whispering to each other through the bedrock. Dr. Ramos's voice is steady but urgent. The data are ambiguous, but we can't ignore the possibility of hydraulic connectivity. If these pathways exist, an eruption at one caldera could destabilize the others. Our models show catastrophe scenarios. Her words hang in the air, heavy with implication. Across the table, rival geologists push back. They argue that the anomalies are artifacts, quirks of imaging, not evidence of a shared system. One veteran volcanologist, arms crossed, counters. Current imaging is inconclusive. Calderas typically erupt independently. Risk is being overstated. The debate grows sharper as new data rolls in. Some point to the 2024 ground deformation at Laguna Caldera, rates never measured before, swelling that defies easy explanation. Others caution that isotope matches could be coincidence, the result of regional geology, rather than a true connection. The room divides into camps, those calling for immediate, sweeping upgrades to the monitoring network, and those warning against panic and budget overreach. A single phrase from Dr. Ramos is repeated in newsrooms and government briefings. Multiple active calderas in the same arc could mean unpredictable outcomes. The uncertainty fuels anxiety at every level, from mayors demanding real-time updates to emergency planners revising evacuation routes by the hour. Scientists comb through every seismic blip and gas spike, searching for patterns that might tip the balance between routine unrest and a chain reaction. The stakes are no longer academic. With lives and billions of pesos on the line, the clash over deep anomalies leaves the country suspended between alarm and inaction, waiting for the next signal from the earth below. 3 years, 1,000 days, give or take, is all the time the planners say the country has to close the gap between what's possible and what's affordable. The numbers are not abstract. In the control rooms of PHIVOLCS, printouts stack up. Requests for new INSAR satellite passes to catch ground swelling in real time. Quotes from foreign contractors for gas array installations on every caldera rim. And urgent appeals for denser seismic grids. Each page carries a price. The international monitoring community, from Tokyo to Geneva, sends their own warnings. Without a full upgrade, the Philippines risks flying blind into the next disaster. On a whiteboard, the priority list grows longer. INSAR expansion to cover every major volcanic arc. Cost, billions. Mobile gas spectrometers to catch sudden surges of sulfur dioxide. Cost, millions more. Redundant satellite uplinks, backup power for remote stations, hardened bunkers for field data. Every item is a line in the ledger, every delay a gamble against the clock. The planner's voice, raw from sleepless nights, cuts through the hum of debate. We have a window, 3 years, maybe less. If we don't act, the next eruption could catch us blind. The urgency is not lost on the room. Reports from the last drill show gaps. Radio dead zones, evacuation routes choked by traffic, sensors offline after the first blast. The cost overruns are staggering, but the alternative is unthinkable. One failed sensor, one missed spike in gas or ground tilt, and the evacuation orders could come too late. International partners offer help, but with strings attached. Grants for new satellite dishes come bundled with training sessions and audits. Foreign experts demand real-time data sharing, pushing for a level of transparency that makes some officials uneasy. Still, the stakes are clear. The next eruption, whether in 3 years or tomorrow, will not wait for budget cycles or bureaucratic delays. In the end, the choice is stark. Invest now, or risk a catastrophe that will make the cost of preparedness look small. The clock is ticking, and no one in the war room pretends they can afford to lose another day. On June 3, 2024, Kanlaon's eruption sent ash 5 kilometers into the sky, forcing the closure of Iloilo Airport and triggering mass evacuations. Documents reviewed in this film confirm a 50 billion peso emergency allocation and confidential government drills for up to 500,000 evacuees. Yet, as Dr. Maria Antonia Ramos states, deep seismic anomalies remain open to interpretation, dividing experts on the true risk. While no Filipino volcano currently shows signs of a VEI-8 super-eruption, the 1991 Pinatubo event proved a single eruption can alter the global climate. Today, a 3-year critical window for improved monitoring is universally recognized in scientific reports, with international agencies urging rapid upgrades to gas sensors and satellite tracking. But as of this broadcast, the full extent of underground connections between these volcanoes is still unknown. The facts are clear. The Philippines faces an unprecedented geological challenge, and only transparent data and continued vigilance can prevent disaster. Utah earthquake shocked scientists. What they're finding is rewriting everything we know about this region. On September 10th, a magnitude 4.1 earthquake struck near Vernal at an impossible depth of 68 kilometers, deeper than Utah's crust should ever allow. More than 150 people felt the jolt, but experts are reeling because the quake came from the upper mantle, where earthquakes just aren't supposed to happen. To make matters stranger, this was a reverse fault in land known for pulling apart. The crust wasn't stretching, it was being crushed by something unknown miles beneath the Rockies. Why is the ground behaving as if Utah has suddenly moved to the Himalayas? Scientists are scrambling for answers, and what they uncover could threaten everything we assumed was stable. What is happening under Utah, and is this just the start? Digital records from the University of Utah seismograph stations tell the story in numbers. At 3:14 a.m. Mountain Time, instruments across the region registered a sudden spike, magnitude 4.1, centered at 40.48 degrees north, 109.705 degrees west. The epicenter sat just west of Vernal, Utah, near the small community of Mason. But the real shock came from the depth reading, 68 kilometers below the surface, more than 40 miles down. That's not just beneath the crust. It's well into the upper mantle, a place where earthquakes in Utah aren't supposed to begin. Seismic stations, both broadband and short period, confirm the numbers. The waveform traces show a crisp, unmistakable arrival of primary and secondary waves fanning out from deep underground. Analysts reviewed the depth calculation, cross-checking arrival times from dozens of stations. No errors surfaced. The depth held steady, 68 kilometers. For reference, the crust in this part of Utah is only about 40 to 45 kilometers thick. Anything deeper means the rupture started in solid mantle rock, not the brittle layers geologists expect to fail. The event's magnitude, while moderate, stands out because of what followed. Over 180 people reported feeling the quake on the USGS Did You Feel It map. That's not typical for a tremor this deep. Usually, the energy from such an event would fade long before reaching the surface. Instead, residents described a short, sharp jolt, enough to rattle windows and nerves alike. The shaking was brief, but it traveled farther than science predicts for a quake with these characteristics. Sensor data paints a picture of an earthquake that doesn't fit the local playbook. The focal mechanism, calculated from the seismic waveforms, points to reverse faulting, compression, rather than the extension Utah is famous for. On paper, the crust here should be stretching, not squeezing. Yet the data is clear. Compressive forces drove rock upward, deep in the mantle, at a spot where geologists have never mapped an active reverse fault. Network coverage in the Uinta Basin is dense, designed to track even minor quakes. This event lit up the grid, triggering automated alerts and manual reviews. The phase arrivals, the timing of P&S waves at each station lined up with a source far below the crust. Uncertainty estimates were low enough for seismologists to stand by the depth, even after rigorous review.